Hi, Year 3. Today we're going on to angles, which is a really nice topic. It's really interesting because it helps us in the world around us to understand shapes in the world around us. This is Year 3 work angles 1. So if you go to library, geometry, properties of shapes, you'll find this lesson. And then after the lesson that you do alongside me, you can go to my portal login to do your work. So let's get going. There's lots of slides on today's lesson. There's 10, so I'm going to try and whiz through them quite fast so that the video is not too long for you. So you'll all remember the right angle is an angle that you turn when you do a quarter turn. And we did a little bit of this in class. I remember I said turn a quarter turn, turn a half turn. We did some of this work before in class. So the spinner has turned through a quarter. Okay, the grey was originally here and it's turned a quarter to the grey being at the top. It's turned one right angle. Okay, you can see here is the pink. That is a right angle. We looked at the squares and cuboids and we said that they had 4 right angles, 1 in each corner. Corner of a rectangle is a right angle, as you can see here, and you can see one here and here and here. Those are right angles. Same with the square. You can see right angles all around you. Okay, here are some examples that I'm going to show you, but then afterwards you could pause the video if you want and see how many you can find in the room. And I bet you can find hundreds in every single room. So if you were looking at the clock and the minute hand was on 12 and the hour hand was on 3, then there'll be a right angle there. There's some on a juice carton, there's some on a stereo. Bookshelves at the bottom if you've got some shelves in your room, maybe on the whiteboard in school or something, and maybe on a letter that's on the table. There's corners would be right angles. You can see many of these are cuboids. So drag the right angles to label on the shapes. Let's have a look at these right angles. We can drag them to label it on the shapes. Remember, you can pause the video and try it yourself. In the meantime, I'm going to have a go. So I can see one there, and I can see this one has 4. I know it's a rectangle or an oblong, so I can do all 4 corners. Here I can see that if I put this one here, then it wouldn't fit because the line is going up the middle of it. So that can't be a right angle. But the top ones, I can see that it is a right angle. This is about a quarter of a circle. We know a quarter is a right angle, so I can see it there. And this one, it doesn't have any at the top. And the reason why I can't do it at the top is it doesn't have an edge at the top. And you could only have a right angle where 2 lines meet. This one, I can see that this one, if I put a one here, it's smaller than a right angle. We're going to come on to what that's called, so it can't be a right angle. But this one is definitely a right angle. And finally, this one, I can see this one only has 1 right angle because if you look here, that one's smaller than a right angle. And then that one's smaller than a right angle. And this one is smaller than a right angle. There we go. All correct. So for every quarter turn, the gnome turns. This is the gnome. Okay, you can see you're looking down on his hat here. You can see his arms there. We're looking down on his hat. Every quarter turn he turns is equivalent to 1 right angle. So let's count how many turns he makes in a full turn if he went all the way around in a circle. 1, 2, 3, 4. So we know in a whole circle, in a whole turn, there are 4 right angles. We can see them all here. So we're going to guide the car through the maze using right angle turns. Okay, you can remember this is a lovely activity. You can try this yourself by going on to the lesson yourself. So you can pause it and give it a go and then watch mine, or skip you could even skip through my bit if you get it all right. Okay, or you can watch. So we're going forwards first, obviously, because the car needs to go forwards. Then I'm going to turn anti-clockwise. Now, anti-clockwise is the way the clock doesn't go. So we know that a clock goes around this way. If you watch my mouse, it goes around that way. So anti-clockwise must be if it goes that way. So we want it to turn anti-clockwise and then forward. And I want it to turn anti-clockwise again. Forward. Now I want it to turn anti-clockwise again. Forward. Now I want it to turn clockwise. Forward. Anti-clockwise. I'm guiding it through the maze. Anti-clockwise. Clockwise. I hope you're doing the same at home, giving it a go, so you can get it right. All the way through the maze. And all of those turns were right angle turns. However, sometimes something might turn less than a right angle or more than a right angle. We don't just have right angles in the world. We have ones which are smaller than a right angle and ones which are larger than a right angle, and we need to learn about these too. So, as we can see, we have a right angle here. And when we label a right angle, we put a square inside the angle to show that it's a right angle. To show that it's a right angle, we label it with a square. However, in another angle, we use a curved line. We would use a curved line. Okay, so we can compare sizes of angles. First, we're going to draw an angle, and we can see we've got a curved line. We know this isn't a right angle because we do not have a square in there. We have a curved line. But we need to know whether this angle is smaller or larger than a right angle. Many of you might be able to see, if we place a right angle over it, it is smaller. Okay, the line is before, if we went across here, we get to this line before we get to the right angle line. Therefore, it's a smaller angle, and we call this angle an acute angle. Acute angle. How I remember this is I think this word looks like cute. And if you say something's cute, you're often talking about something that's small. So that's how I remember. Acute angle is small. An acute angle is smaller than a right angle. Try and repeat that many times. All of these angles, you can see this one's really small, are smaller than a right angle. They are all acute angles. Here's another angle. And we can see that this one, we hit the right angle curve, cross section, before we hit the other angle cross section. So this one we know is bigger than a right angle. We know it's bigger than a right angle, and we call it an obtuse angle. Obtuse angle. Okay? How I remember this is if you say something's obese, you mean obese means really big. Obese, the word obese means big. Okay? In any sense of the word, you could say there's an obese elephant outside. Okay? So, obese angle must be bigger than a right angle. That's how I remember it. So really try and remember those. Drill them into your head. Acute is smaller. Obese is bigger. Another word that I just thought you could remember is ob. The B, you can remember if it has a B in the word, then it must be big. Ob, big. Okay, whereas acute doesn't have a B in it. So all of those were acute angles. So let's have a look. We can see here that every single one, they're comparing with a right angle. And it's good. It's a really good way of checking work. Even though this one here very much looks bigger than a right angle, they still checked it against the right angle to make sure that they were sure it was bigger. Obtuse. So it's our turn. So we can look here. It's bigger. Here, bigger. So that one's an obtuse. You can repeat it with me. What's this one? Acute. This one, acute. This one, acute. Have a go on your own lesson as well, remember. So, sometimes it's not clear whether an angle is greater or less than a right angle. And that might be because the angle is rotated. Have a look at this one. this angle, we don't have a straight line across the bottom. We don't have a horizontal line, as we call it. We're about to come on to lines, and a vertical line. We don't. We just have two lines. And it's very hard to see whether this is the same as a right angle, slightly smaller than a right angle, or slightly bigger. We might be able to guess, but guessing isn't very good because we won't be sure. We won't know that we got the right angle. So here, if something like this happens, how do we measure it? We need to rotate it so that one of the lines is horizontal, and the horizontal means across the bottom. Now, some of you may see that this angle, some of you may be able to see by eye whether this angle is smaller or bigger than a right angle. Here, we put a right angle over top, we can see it's slightly bigger, so shout out to the screen, what type of angle is it? I'm hoping you all shouted obtuse. So I can't seem to rotate this one, which is very frustrating here. And then I can rotate it. And I can see if I put the horizontal line exactly on it, I can still see the pink line slightly before the other line. So I know this angle is obtuse. It's a bit fiddly, but you can give it a go. So we're moving on to different types of lines. Now, as I said, the horizontal line is the one that runs from left to right across, for example, a page. A line that runs from left to right. So this would be a horizontal line. If you got a glass, and you can go and do this if you want, this little experiment, okay, and filled it with water, you would see that the water is on a horizontal line. The line runs from left to right, horizontal. If you tilted the glass, no matter what angle you tilted it, the water would still be horizontal. Water can't not be horizontal. It can't magically go at different angles. It will always be horizontal, and that's due to gravity, if you're interested why. Okay, unless you tip it too far, then the water will fall out, so there'll be no water. So you can have that a go if you want. The word horizontal comes from the word horizon, the line where the sky meets water. Okay, so you might have gone to the seaside and you've said, I can see all the way to the horizon, the line that runs all the way at the back of your view. Okay, so that line is horizontal. The horizon is horizontal, just like a horizontal line on a page. It runs from left to right. A vertical line is one that runs up and down. So, in a square piece of paper, you can see all the lines that run up and down are vertical. What do you think we call the ones that run the opposite direction, left to right? I'm hoping you all said horizontal because we just went through that. There we go. Any line that is right angle to a horizontal line will be vertical. Okay, so if we had a horizontal line here and then we had an exact vertical line from the sail, then this must be a right angle. Okay, horizontal and vertical lines, wherever they meet, remember we can't have an angle unless two lines meet, but wherever they meet would be a right angle. So pendulum and swing clock, when it's not swinging, it's at a right angle to the floor because it's straight down, the pendulum, and the floor is straight across. If it was swinging, then it wouldn't be the same because it would be moving and it wouldn't always be vertical. So it says, how many horizontal lines can you find on the robot? You can pause the video and count how many vertical lines you can see. The answer is, horizontal lines. I'm very sorry. I hope that you paused the video and you thought Miss Maletta is being very silly there because it was talking about the horizontal lines and I read it wrong because I am not very clever. Okay, I'm hoping you all noticed that. There are 14 horizontal lines on the robot. We can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well done if you got one of them. Now, see how many vertical lines you can find. Pause the video and have a go. I'm hoping that you found them all. There are 13 vertical lines. So I'm not going to do this one because I don't want to take up too much time, but you can have a go at this one. Remember, by going into the lesson on just the first page of My Maths, all you have to do is type in Bluecoat 1 and the password, and you get onto this page. Not my portal login, otherwise you won't find the lesson. And go to Library Geometry and then find it. You can have a go at this. Drag each letter below into the correct box. So, which ones have horizontal lines? Which ones have vertical lines? Which ones have both horizontal and vertical lines? And which ones have none? Okay. For example, the S. Okay. I can see here that it goes all the way around, but there are no angles. It's one line. There's no angles. Therefore, I know that one would go in there. And I'm sure you can carry on with the others. Which ones have them? Give it a go. You get 10 out of, if you get all of them right, that would be really impressive. Final slide. Perpendicular and parallel lines. We covered this ever so slightly earlier in the week. We say parallel lines are two that run alongside each other, and they will never ever touch. We sometimes show them with arrows to show they're going in the same direction. When two lines cross or meet at right angle, perpendicular lines like a horizontal and a vertical line, horizontal and vertical lines, should do it that way, they are perpendicular. Anywhere where there is a right angle, you call the lines perpendicular. Okay? So I went through that quite fast, but you can have a go at this. Click on two lines which are parallel. I can see that these two lines are running alongside each other and they're never going to touch. So I know that those two are parallel. Good. And which two lines are perpendicular? I can see this one is going horizontally and this one is going vertically. So these two lines must be perpendicular. Good. Hope you enjoyed today's lesson. Tomorrow we're going on to one more angles lesson. Okay? And have a lovely rest of your day. Don't forget to do your work through the portal.